Okay, so the number of elements in the array, you use the array name and write dot length, and that tells you the number of elements in the array. Right? That's an int value in Java. Right? So here n will be equal to 10. Right? If you leave this line out and write int n equals collection.length, you get an error. Right? So be careful about that. Right? So again, remember, when you write this line of code here, there is no array yet. Right? You've got a variable, it can hold an array, but there is no array yet. Right? Which is a bit unusual, especially coming from a language like Python. Right? Here, now there's an array. Right? So now you can ask for its length. If you took this line and moved it up here, you would end up with an error. Right? Oddly enough, you end up with the error when you run the program in this case. Right? And you'll get something called a null pointer exception. Right? And you'll get some error message that says there is no array called collection. Okay, so the elements in the array, so the values in the array are called elements, similar to, hopefully they called them elements in your 121 class, right? So similar to the values in a Python list, right? The last valid index is always the length of the array minus 1. The first valid index is always 0. If you try to use an index outside of that range, you'll get an error. Right? So here's an example where I make an array. Oh, sorry, I'm going to assume, oops, sorry, back here. Right, so let's assume we've run this line here. So we have an array of 10 values. Right, I can now fill them in, manually in this case. Right, so the first element is 100. Right, if I want to get the first element, I can just use the index 0. Right? You can use any index here up to 9, and that's fine. Right? Remember that Java fills in the values of the array for you if you haven't done it already. Right? I can go ahead, fill in the rest of the values that I want. If I try to use a value that's out of range, right, so equal to the length of the array or negative, you end up with what's called an array index out of bounds exception when you run your program. Right? So Java, just like Python performs, will check an index before it actually tries to use it. Right? If the index is not valid, in Java you get an exception. In Python, you get an error of some kind. Okay, so now that you've got your loop, now that you have an array, you have multiple values, right? You probably want, many of the operations that you want to perform on the array probably involve doing something with all of the elements in the array, right? So you need a loop now. So when you're working with a Python list, right, one of the most common things that you do is you loop over the elements of the list. Right? So if I want to find the maximum value in a non-empty list, one way to do it is to write a little loop. Right? So here I've got a function called maxElem, finds the largest element in T. Right? This only works if the list is not empty. Right? If the list is empty, then T0 will cause an error in Python, just like it'll cause an error in Java. Right? I'm going to assume the first element of the list is the largest element. Right? And now I need to look at all the other elements in the list. So in Python, Python only has one for loop. Right? So Python has a for each loop, and that's all that it has for loops. Right? So for every element in T, right, it's going to go through the list starting at index 0, and the first time through the loop, elem will be equal to T0. Right? Second time through the loop, elem will be equal to T1. Third time through the loop, elem will be equal to T2, and so on and so on and so forth. Right? So if you find an element that's greater than the current largest element, you know that your new largest element is equal to that value. Right? Process all of the elements in the list. When you're done, return high. Right? Return the largest element that you saw. Okay, so Java also has a for each loop. Right? So I want to make a Java method, so public static. Right? Now remember, Java methods, if they return a value, you have to say what type of value is it returning. Right? So to determine what type of value it's returning, I have to decide what kind of array am I looping over. Right? So notice Python here, this will work with an array of any type, as long as you can do greater than. Right? So you can use a float, or you can use an array of int. You can use an array, a list of ints and floats. This will work just fine in Python. In Java, that's not the case. Right? Here, I can process an array of doubles. Right? If I want to process an array of int, I have to write a separate method to do that. So if I want to find the largest value in an array of double, I'm going to return a double value. Okay. And now the code basically looks the same, right? High is going to be the current largest element that I see, so that's going to be the element at ARR0, right? And now the for loop looks different than the Python for loop. Right? So keyword for is the same, right? You must use round brackets here, right? And now instead of elem in t, right, you write elem colon ARR, and you have to say what is the type of the element. Right? So the element type is the same as the element type in the array, so the double goes here. Right? Elem is just a name, it's just a variable name, right? So you can call this whatever you want. Right? Instead of in, it's the colon, and then the name of the list and the name of the array in this case. Right? Everything else now is the same except translating Python to Java. Right? So if elem is greater than high, high is equal to elem, and then after the end, return high. Yes, question? Is this question? You will not see, I will not ask you to write a loop, a method that finds the maximum element in an array. This is something that everyone here should be able to do without thinking about it. I don't even understand your question. So. There could be, but I'm not going to tell you what questions are on the test. But yes, there could be a question like that. Okay, so here, this is actually a variable declaration, right? So this variable elem has a scope, right? The scope of elem is the body of the loop. So you can use elem inside the loop, right? If you need it after the loop, this won't work. Right? So the name elem does not exist after the loop. If you need to use it after the loop, you have to declare elem up here. So you'd write double elem here, semicolon, and now here you would write for elem colon ARR. And then elem would be available to you after the loop. Right? Here, it's the scope of elem is the body of the loop. Most loops that you will write, the loop variable only needs to work inside of the loop itself. Right? Usually, you don't need the loop variable after the loop. There are cases when you do. Okay, so instead of finding the largest element, I might want to find the, did I do this right? Return to find the index of the max. Oh, no, there's a bug. Boom, boom. Sorry about that. Okay, instead of finding the maximum element in a list, you might want to find the index or the location of the maximum element in the list, right? Because you might want to change that value, right? If you just get back the largest element and you want to change it, you now have to search the list again to change the value, right? So instead, you might want to know where is the largest value in the list, right? So in this case, I need the index of the element. So here, the easiest way to write this is to write your loop so that it uses the index of the element, right, rather than using the element directly by itself directly. So to find the maximum index, I'm going to assume the largest element is at index 0. Right? I'm going to set my current largest value to that element, right? And now when I write my loop, right, I'm going to use a loop variable called I, or index, or ind, or in, not in, ind, or something like that. Right? Python only has one kind of loop, right? It only has the for each loop. So if you want to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you have to use this thing called range, right? So range 0, comma, length t. In Python, that makes a range object that can count from 0, 1, 2, 3, 4, 5, up to length t minus 1. Right, which is exactly what I want. Right? So I is simply the range of the valid indexes for my list. Right? And now my if statement, I'm going to look at ti instead of looking at the element itself. Right? So now I need to get the element, so that's the element at index I. Right? If I find an element that's larger than the current highest value, I have to remember its index. It's useful to also remember the largest value. Right? And then finally, when I look at all the elements in the list, I can return the index corresponding to the largest element. Okay, so Java has a second kind of for each loop. A second kind of for loop, right? The second kind of for loop was the original for loop in the Java language. It comes from the C language. So the original for loop in Java, or the normal for loop in Java, is a counting style loop, right? So the way you write this thing here is that you create a loop variable the same way that I did here, right? So I is my loop variable. Here, I is my loop variable, right? And I'm going to set it to 0. So I is an index. All indexes in Java are ints, right? So I'm going to set it to 0, and then I'm going to use a semicolon, right? I'm then going to write I is less than the length of the array, right? And so this condition here is the condition that is checked before the loop runs, right? So if the value of I is less than the length of the array, the body of the loop will run, right? After the loop runs, so right here, whatever is here now runs, right? So this is the loop update expression, right? So int I equals 0, semicolon. Semicolon has to be there. I is less than the length of the array, semicolon. Semicolon has to be there, right? Each time through the loop, I want I to go up by 1, right? So I want to increase the value of I by 1. So you can increase the value of a variable by writing I++, right? So I++ means, for the time being, it means add 1 to the value of I, right? And now the rest of the code looks the same as before, right? And so a counting style for loop in Java, or a regular for loop in Java, most people just call it a for loop in Java. If you are talking about a for each loop in Java, then people call it a for each loop. So it's a little bit different than in Python. So the regular for loop in Java has 3 parts. There's an initialization expression, so that basically declares the loop variable and gives it a value. The second part is what's called the termination condition. So this determines, it's called termination condition, so it looks like it determines when the loop ends. Really it says when does the loop run. So if this condition is true, the loop will run, and if the condition is false, the loop will stop, right? And you'll go down to the after the loop. And then finally, you have the update expression. So this is what happens after the loop body runs once, right? Every time it runs, every time the loop body runs, the update expression runs after the loop body finishes running, right? So for every iteration of the loop, the update expression runs at the end of the iteration. Now, the interesting thing about the Java for loop is that all 3 parts are optional. The semicolons are not. So even if you have none of the 3 parts in the loop, the semicolons are still required. Okay, so what does the initialization expression do? So it's the first part of the loop, right? Basically that declares any of your loop variables, and then it sets the value of the loop variable, right? So this is the normal way that you would write a counting style loop, where you're having a count, where you're using an index variable I. The second part is the termination condition. And so before the loop body runs, right? So right here, right, the loop checks this condition here, right? If this condition is true, then the loop body will run. If the condition is false, then the loop exits and you end up down here, right? So the loop stops running and you end up after the for loop, right? So every time before the loop runs, right, that condition gets checked. And finally, the update expression is the thing that runs immediately after the loop body runs each time. So if the loop body runs here, then right here, I guess, is where that update expression runs. Right, so here I'm writing I++, and so this increments I by 1 at the end of every time the loop runs, right? So I++ has the same effect in this case as writing I equals I+1, right? Now you have to be careful about translating I++ to I equals I plus 1. It turns out they don't exactly mean the same thing. There is a subtle difference, but for the time being, it's fine, right? I++ means increment the value of I by 1, right? You could write it out manually as I equals I plus 1, that's fine. Right? Another way to write it in Java is to write I plus equals 1. Right? And so this also takes the value of I and adds 1 to it and reassigns it back to I. So that's what this plus equals means. Right? So take I, add whatever this is back to I. Right? And so there's 3 different ways you can write this. They all have very subtly different meanings. Most of the time, it doesn't matter which one you choose. There's actually a 4th one. I forgot, sorry. Another way you can write it is plus I, which looks very similar to the I++ that's here. Again, the meaning of all of these operators, there's a slight differences between all of them. For the time being, it's not important which one you use, right? They will all do the same thing. Right? Okay, so there's another problem with the for each loop, right? So with there's many cases where when you're writing the loop, you need to access more than one element of the array at the same in the same loop iteration, right? So in the examples we've seen so far, we've only been looking at the current element that the loop is at in the iteration, right? In the case of solving the problem, is this array sorted? What you want to do is you want to look at 2 values in the array at the same time, right? The for each loop only lets you look at 1. So this is another situation where you probably want to use a regular for loop. You can write a for each loop, it just becomes more awkward to do it, right? So if I want to look at 2 elements at the same time, it's probably better to just use an index, right? So to check if a list is sorted, what you want to do is you want to look at the first and second elements, right? So if I'm sorting in ascending order, I want to look at the first and second element. If the second element is smaller than the first element, I know it's not sorted, right? If the first element, if the first two elements are sorted, then I want to look at the second and the third element and check if they're in sorted order, right? And then the third and the fourth, first, second, third, fourth, fifth, and so on and so on and so on, right? So here you want to look at every pair of adjacent elements, right? So in other words, what you want to do is this, right? I want to look at the first and second elements. These are sorted, so the loop can continue. Right? I now want to look at in the next iteration, I want to look at the second and third elements. Right? These are sorted, so the list can continue. Right? I want to compare the third and the fourth. Right? Eventually, you get down to here. Right? So I'm comparing the third last and second last. Right? Then the second last and the last element, and everything is in sorted order. So here I can finally return true. So how do you write that out in code? Okay, so you begin by assuming the list is sorted, the array is sorted. Right, so is it sorted? Yes, right? We're just going to assume that the answer is yes. Right, I now want to look at every pair of elements, right? And so there's a bunch of different ways you can write this loop. Right, here I'm going to start by writing, by making my loop variable I, right? And I'm going to set it to 1 instead of 0. Right? As long as I is less than the length of the array, so remember I is my index, right? I want to look at all the elements in the array, right? So as long as I is less than the length of the array, the loop should run, right? Each time through the loop, I want to increase I by 1, right? Now, I want to look at the element at index I, and I want to compare that to the element in front of it, right? So the element in front of it is just the element at index I minus 1, right? So here, right, I can access a second element of the array because I have an index I, right? And I can do arithmetic with that index, right? So is the previous element greater than the next element, right? If that's the case, it's not sorted in ascending order. It might be in descending order, but I'm checking for ascending order, right? So if I ever run into the situation, I know the list, the array is not sorted, and I can set is sorted to false, right? I now keep on going, so we process every pair of elements, right? And eventually you're going to either return true or false, right? Notice the way this loop works, right, is it's trying to falsify the assumption here, right? So assume that it's true, right? When you find a situation where it's not sorted, set is sorted to false, right? Whatever you do, don't stick in an else statement here and say is sorted is true, right? You're not keeping track of whether you're not, because that's going to flip back and forth. It's going to flip is sorted back to flip it back and forth between true and false repeatedly, right? If the last two elements have order, right, your method will be returning true instead of returning the correct answer of false, right? So here I'm trying to find a situation where the list is not sorted, and as soon as the list is not sorted, you never want to set is sorted back to true. Right? So whatever you do here, don't put in the else statement. The logic in your loop is incorrect. Right? And so there's is sorted. Now, you might ask yourself, look, if you look at, if the first two elements are not sorted, right, you know that the rest of the list is not, the rest of the array is not sorted, so you can stop, right? It's not sorted, so you can stop. So if you want to stop a loop, the way you do that is with the break statement. And so the break statement, hopefully they showed you this in 121, right? Python also has a break statement. It will break out of a loop, right? So what break does is it jumps outside of the loop that it's in, right? So if we find a situation where the list is not sorted, break immediately jumps out of the loop and goes to the end of goes to the point immediately after the loop, right? So here we can stop checking elements as soon as we know the array is not sorted. Right? Put it in a break statement, and away you go. Right? So putting in the break statement here saves you some work. Right? Instead of looking at all of the elements in the array, right? Look at enough elements in the array until you know the answer, and then you can stop. Right? That's what the break statement does there. They did show you break in 121, right? Okay, good. All right. With this particular array, right? When we find an element 15 that is smaller than the element in front of it, right? Or equivalently, when we find an element 99 that is bigger than the element after it, we know that the array is not sorted, so you can stop and return false. Okay, here's another example. The loop must access or wants to access more than one element of the array in the same iteration. Right? So to reverse the elements if you have an array or a list and you want to reverse the elements, right? The idea is you want to start with the first element and the last element of the array and switch them, right? So you want to swap their positions, right? You then want to take the second element and the second last element of the array and swap their positions, right? And so on and so on and so on until you've swapped all of the elements in the array, right? So I know the first element in the array is that has index 0. So I is going to keep track of the element in the front half of the array, right? I need to also keep track of what element am I swapping with at the end of the array, right? And so that's going to be j, right? And notice here, I'm declaring j before the loop, right? So for the first, what is the location of the last element in the array? Well, that's the length of the array A, so that's A.length minus 1, right? So that's the index at the back of the array. In the loop, right, I want to swap the elements at AI, I want to swap the elements AI and AJ. Stuff in 121, right? Yes? Okay, so remember, if you're going to swap two values in most programming languages, you need to introduce a temporary variable, right? So you have to remember the value of one of the two values that you're swapping, right? And then you can switch the values using the temporary value to help you. So I'm going to remember the value at AI, so I'm going to remember the value at the front half of the array, right? Once I've remembered the value at the front part of the array, I can update that value, right? So I can take AI and I can set it to AJ, right? So assign AJ to AI, right? So in other words, copy the element at the back to the element at the front, right? Now, you've overwritten the element at the front. This is why you needed the temporary variable, right? That's why you needed to remember what the old value of the variable was, right? So to move the, or to swap the first element of the array to the last, right? You now reassign the last element of the array to your temporary variable, right? So that swaps the first and last positions of the elements of the array, right? Now, the loop, the counting loop is going to keep track of the index I, right? So each time through the loop, I is going to go up by 1, right? We're keeping track of the ending index ourselves, so that means we have to update the ending index ourselves here, right? So there's that j minus minus there, which is a very, the very easy mistake to make is to forget to increment j, or decrement j in this case, right? So here you have to be careful. You have to remember, oh, I have to adjust this value j as well, right? Because I want to, on the next iteration, I want to swap the second and second last, right? And then the third and the third last, and so on and so on and so forth, right? The other thing you have to pay attention to here is when does this loop stop, right? Notice the termination condition here is not I is less than the length of the array, right? Remember, I is the index in the front half of the list, and j is an index in the back half of the list, right? As soon as I and j cross, right? So as soon as j becomes an index in the front half and I becomes an index in the back half, right? You want to stop, right? If you don't stop, you switch the first and the last, and the second last, and then when you get to the middle, you're going to switch all your elements again. So what you end up doing is putting the list back, the array back into its original order, right? So here the loop termination condition is when, as long as I is less than j, right, the loop should run. So this is a picture of what's happening, right? First time through the loop, right, I'm going to swap these two elements, so the 12 and the 27, right? Second time through the loop, I'm going to swap the 13 and the 26, right? Third, and so on and so on and so forth, right? Now, at some point, I is going to be 7 and j is going to be 8, so I'm going to switch the 19 and the 20, right? As soon as I do that, I'm done, right? If you keep on going, I is going to be here, sorry, I will be here and j will be here, right? So if I switch these two, it's 2019. If I keep on going, I'm going to switch them again, and you're going to end up with 1920 again. And then the 21 and the 18 will swap, and then the 22 and the 17 will swap, and you will have unreversed your list, right? So you need to stop here, right? And so now the loop stops, because I and j are going to cross one another, and you don't want to re-reverse the list. Right? Okay, and so in this example here, right, there's really two loop variables, right? There's I and there's j, right? And so in Java, you can write a loop using more than one loop variable, right? So here, instead of declaring j outside the loop, I can declare j when I declare I, right? So int I is equal to 0, right, comma, right? J is equal to the length of the array minus 1, right? Similarly, in the update expression, you can update more than one thing if you want, right? So I can increase I by 1, and I can decrease j by 1. So j minus minus is like I plus plus, except it subtracts 1 from j, right? J minus equals 1, plus plus j, they will all do something similar, right? So you can also write the loop like this, right? And that saves you from having to remember to update j yourself down here, right? Which is nice. You have to be careful when you do this. So to do this, there are some restrictions on what you can do, right? So you're only allowed to do this if I and j have the same type, right? So here this works because I and j are both int. There's no way to declare two loop variables that have a different type in Java. So if you really like Java's for each loops, You might try to write every loop, every for loop with a for each loop, but eventually you'll run into a situation where you cannot. So where you use a for each loop is when you are trying to access elements from more than one array at the same time, using that the loop as to access the element. Right? The for each loop lets you iterate over one array. Right? If you need to iterate over multiple arrays, you're stuck. Right? You have to use the counting style loop. So if I want to sum the elements of two arrays, right? So I have an array A, say it has 5 ints in it. I have an array B, it has 5 ints in it. I sum element by element, right? So A plus B0, A plus B1, and so on and so on and so on, right? And I would like to return the result as a new array. Oops, sorry, right? So notice here, our return type is an array of int, right? It's equal to the sum of the values of A and B, right? So step one, make an array that we can return, or make an array that we can use to hold the sums, right? Now write your counting style loop, right? Summing elements AI and BI and storing it in CI, right? So CI is just equal to AI plus BI, and away you go, right? So here we're accessing 3 different arrays with the same loop variable, right? There's no way to do this for each loop. Right? In Python, you would also have to use a for each loop with a range to do this. Right? There's no way that you can write a range-based for each loop in Python and compute this sum. Okay, so Python with Python lists, you have a way to slice a list. Right? You can get a sublist from an existing list, which is really handy in many cases. So the slice in Python uses the colon operator. In Java is used in the for each loop of the array of the list T, starting at the 3rd element, going up to but not including the 6th element, right? Element at index 2, up to and including not the 5, right? So 2, 3 elements at indexes 2, 3, and 4. Right, so 0, 1, so 2, 3, and 4. So that should give me the sublist 12, 13, 14, right? Which it does, right? Slash T colon gives you back a copy of the entire list. So that's the Python way to copy existing list. Right? Java has no slice operator for the arrays, and it has for proper Java lists there is a method that corresponds to a slice, right? But there's no slice array. So you have to write your own method if you want to slice an array. So I want to slice an array of int using a starting index and a stopping index. The slice does not include the element at the stopping index, right? So I want it to work the same way as a Python slice. Now, the slice in Python is a list. So a slice of an array in Java ought to return an array that has the same type as the input array. Now for the slice, the start value should be less than the stopping value, right? Less than or equal to the stopping value. If it's not, there's probably, you either have to guess at what the slice is, you have to guess at what the programmer actually wants the slice to be, right? So here we're going to enforce the constraint that the starting index must be less than or equal to the stopping index. So we check, is the starting index greater than the stopping index? And if it is, we say that I can't slice that list, or that array, sorry. So we throw an exception here. Right. There are other things you need to check for as well, but we'll come back to that in a second. Okay, so to compute the slice, you need somewhere to store the slice, right? Because I need to store the array containing the slice, right? How long is the sliced array? Well, it turns out if you take stop minus start, you get the length of the returned array, right? So here, it's 5 and 2, so that's 3, right? And there are, in fact, 3 elements in the returned slice. If stop and start are equal to one another, you get 0 here, right? And so this is legal in Java. You can make an array that has 0 length, right? In other words, it's the array that holds no value. So that's legal in Java. You can, just like you can have 0 length in Python. Right? So we compute the array to store the slice, and now you compute the slice. right? So I want the elements from ARR starting at that index, right? So my I in this case is going to be the index that I'm using to access the array ARR, right? So I is going to start at start, right? It's going to go up to, but not including stop. Okay? So I is going to be less than stop. Each time through the loop, I'm going to add 1 to I, right? Okay, so I can get the element out of ARR pretty easily, RRI. The only trick, or the only thing you have to be watch out for here is where do you store the element of ARR in slice, right? So remember, slice starts counting, this element in slice starts counting at 0. So the index here that I need, right, I have to subtract start from the value I to compute the correct index for the slice. Right? I minus start is 0, first time through the loop. Second time through the loop, right? This will be start plus 1, so that's second time through the loop. This will be third time through the loop. This will be start plus 2, so that'll be 2, and so on and so on and so forth. Right? So sometimes you have to compute an index. Right? Whenever you compute the index, make sure that the computed index is a valid index. All right, what other things do I have to check for up here if I'm using start and stop as an index? Right? So I really should check to make sure start and stop are 0 or greater, right? Because in Java, you can only have indexes are always non-negative, right? You should also check to make sure that start and stop are both less than the length of the array, right? Make sure that they are, in fact, valid indexes. All right, so there is your method to slice an array if you want it. Right. If you want to use that method, you can just call it, again, by the class that it's defined in, so lecture4.slice, right? Pass in the array, and then the start and stop indexes. Right? Notice the syntax here, compared to Python, is not as nice, right? You have to actually call a method here. Whereas in Python, you can just use the square brackets and a colon. All right, so there's your slice method, and that's an example of returning an array, throwing an exception, using and computing indexes for an array. Any questions on how to slice an array? Okay, so that finishes up the loops. Of course, like in Python, you can have nested loops, so a loop within inside of a loop, right? It works, the syntax is different, but it works the exact same way.